All right. In this Algebra 1 video, I'm going to be going over quadratic formula. Just make sure my camera is straight. There we go. So I'm going to be going over quadratic formula. And this is another resource you have in finding the x-intercepts or the roots for a quadratic function. First thing I'm going to do is I'm going to derive it for you so you understand how it is that I'm going to be using it. So I'm going to come up first with my equations. Let me just grab my markers. You recognize that the very first thing I have is I have my quadratic standard form, ax squared plus bx plus c equals 0. Okay? And what I'm going to do is I'm going to show you how I'm going to solve for x using my generic standard form equation of the quadratic function. First thing I got to do is move my c over. So this seems very similar, right? So I'm going to move my c over. And then I have ax squared plus bx is equal to negative c. I need to just work with x squared. So what I'm going to do is I'm going to divide everything by a. Everything gets divided by a. Okay? The only one that cancels out is that guy right there. So I now have x squared plus b over ax is equal to negative c over a. Have we seen this before? Yes, this is, I'm kind of putting it into vertex form. So this is going to give me a completing the square situation. So I'm going to go ahead and I'm going to create a perfect square with this guy. So this is just like when I use the completing the square method. I'm going to create a perfect box. First thing I'm going to do is I'm going to put my x squared here. Now, this guy must be the sum of these two things in the middle. So, sorry. These two must be identical terms and must add up to this b over ax. So, I needed to put two things that are identical and they must add up to b over 2a. So, wouldn't that be this number in half? So, watch. I'm going to do a little side analysis here. What's half of b over ax? Well, I'm going to go top. That's 1bx over 2a. See that? So let's see. If I add a bx over 2a and a bx over 2a here, doesn't that give me that? Let's see. Bx over 2a plus bx over 2a gives me, I'm going to do it here. That gives me 2bx over 2a. Well, those cancel. Isn't that the same as that right there? So that's going to be my answer now. I'm going to go ahead and find my factors. So for my factors, let's do purple. So what do these guys have in common? These right here, guys, just have an x factor in common. X times what gives me x squared? That's an x. X times what gives me that? That's a b over 2a. So positive b over 2a. Because that's x over 1. So x over 1 times that gives me bx. 1 times 2a gives me that. So x times what gives me this? Another b over 2a. And now that I have this, what's the term here? Well, top gives me b squared. And bottom, 2a times 2a gives me 4a squared. So this homie right here is what I'm going to add to both sides. So I am simply completing the squared. Okay. Now I am able to take this right here, this little trinomial, because it has 3 terms, and I'm able to write it in factored form in its perfect square form. So if you notice that this is x plus 2b, x plus b over 2a, and this is x plus b over 2a. So now I'm able to write this as x plus b over 2a squared is equal to negative c over a plus b squared over 4a squared. Okay? Now, So far, I hope you're following along. I need to make sure that these two guys here, because I'm adding fractions, must have a same common denominator. This has a denominator of a, this has a denominator of 4a squared. So if I plump this guy by a 4a, 4a times a is going to give me 4a squared. So that's exactly what I'm going to do. I'm going to plump this guy. What I do to the top, I do to the bottom. Remember that? Like that. So now my new equation is going to say x plus b over 2a squared is equal to negative 4ac over 4a squared plus b squared over 4a squared. 4ac, but there's a negative, so negative 4ac. Okay, so now I'm going to just rewrite this, the b squared first, because, it's easier to have a positive first. So I'm going to go x plus b over 2a quantity squared is equal to b squared. And now that they have the same common denominator, I'm just going to put it b squared minus 4ac, same common denominator, 4a squared. Okay, so I'm getting ready to solve this. So now I'm able to say, okay, I'm able to undo this square with a square root. What I do to one side, I do to the other. So this square root and this square cancel. I now have x plus b over 2a is equal to, now remember I took a square root, so because this is a square, I have to include both plus or minus of b squared minus 4ac. Now I'm going to do another side little note. Square root of 4a squared gives me radical 4 times radical a squared, which gives me 2a. So on the bottom, I have 2a. Okay. Next thing I'm going to do is I'm going to move this b over 2a to the other side. So I'm going to subtract b over 2a to both sides. My final equation is going to say the following. This is now going to say the following. X equals negative b over 2a, plus or minus the square root of b squared minus 4ac all over 2a. Okay? So now if I want to notice that I have the same common denominator, so I'm just going to go ahead and just put it all in the same common denominator. Negative b plus or minus square root of b squared minus 4ac all over 2a. This right here is the quadratic formula, and if you know how to use it, you are able to find the zeros automatically going from standard form using the quadratic formula. Okay, so let's do an example. Okay, so this right here is a quadratic formula. Let's do an example. I'm going to do with an example of one that I think I've done in a previous video. So let's say I have f of x is equal to x squared minus x minus 56. Okay? First thing I'm going to do is I'm going to let it equal to 0, because if I want to find the zeros. So my thing is find the zeros. Find the zeros, x-intercept. I'm going to use the quadratic formula. So by using quadratic formula. Okay. First thing I got to do is let this equal to 0. So I need to make sure that it's in standard form. So it's going to be x squared minus x minus 56 equals 0. Next thing I'm going to do is I'm going to identify my a, my b, and my c. I know my a is 1 because 1x squared. My b is negative 1 because negative x is the same as negative 1x. And my c is negative 56. Now I'm going to proceed to first, you must always start with the formula. So it's going to say x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, now I'm going to go ahead and I'm going to use parentheses, and I'm going to go ahead and plug this into the formula. Notice there's a plus or minus, so you have a possibility of having two answers. Okay, So I have x equals negative, -1. That negative does not mean it's the same negative. There's two. That is part of my formula, and that's my value. So that's why I have negative, -1, plus or minus square root of -1 squared minus 4 times 1 times -56. All over 2 times 1. So again, all I did is I took my formula and I substituted the A, B, and C values that the formula asked me to use. And now I'm going to use order of operations to simplify this. The very first thing I'm going to do is I'm going to simplify this and the inside of the radical and then that individually, okay? So I have x equals negative gives me 1 plus or minus, and that's going to give me -1 squared is 1. A -4 times 1 times 56. So here it's not subtraction. I need to simplify this multiplication first. So I have 56 times -56 times -4 times 1 gives me positive 224. So a negative times a negative gives me a positive 224 all over 2. Okay. Now I get to simplify the inside of that, so that gives me x equals 1 plus or minus square root of 225 all over 2. Square root of 144 is 12. Square root of 169 is 13. Square root of 196 is 14, I believe. Let me see. Yeah. And let's see what 225 gives me. 15. So square root of 225, I'm going to just put it right here, is equal to 15. So I now have x is equal to 1 plus or minus 15 over 2. Now this is the most important part here, is that I'm going to separate this into the plus summation and the negative. So this is going to say option A, or case 1, x equals 1 plus 15 over 2. And then I have the other one, which is case 2, x equals 1 minus 15 over 2. So 1 plus 15 gives me 16 over 2, which is 8. So I have x equals 8. And then over here, 1 minus 15 gives me -14 over 2, which is -7. And this gives me x equals -7. So I found the values. Let's see if we can compare this. If I want to do I want to see if I get the factored form. So I'm going to go ahead and play my little game, b plus ac dot, and I have -1 and -56. That means I have a -8 and a +7. So when I put it into my box, I get x squared minus 56 minus 8x plus 7x. That gives me the following. That gives me x plus 7 and x minus 8 equals 0. And if I let them and I solve, x equals -7, or x minus 8 equals 0, add 8 to both sides, x equals 8. Did I get the same answer as I did over here? Yes. So this is showing you how you use the quadratic formula. The quadratic formula is also our gateway to looking at imaginary numbers, and we're going to take a look at that in a little later lesson. But at this time right now, I would like you to understand how this formula must be memorized. This is the quadratic formula, b plus square root of b squared minus 4ac all over 2a. Notice that this is all over 2a. Again, just to recap, make sure your equation is in standard form, which is ax squared plus bx plus c equals 0. Identify your a, b, and c values there. Start with the formula. The very first step is you rewriting the formula, and then you're going to substitute and simplify. There will be two cases, one plus case, one minus case, and those are the zeros that you're going to have. So enjoy this week's lesson. Have a good day, everybody.